Alright, so here we are with the 4-7 pre-calc notes on evaluating inverse functions. So, we just want to be clear that we're talking about inverse functions and we're not talking about reciprocal functions. Reciprocal functions are things like cosecant, secant, and cotangent. Okay, but again, that is not the same as inverse. So, taking a look at our notation for inverse, the idea is that you actually have this word called arcsine or arccosine or arctangent, and that's because the symbol that we actually use, and you can find it on your calculator, is sine with a little -1 or cosine or tangent, and then of x. And the problem with that little -1 is that it starts to look like something like x to the -1, which actually means 1 over x. But of course, this does not equal 1 over sine. Okay? Because 1 over sine is cosecant. Cosecant. So we got to watch out for that. So either way, it's the one on the calculator, and it is the opposite or inverse of the sine. So basically, if you take sine inverse of sine of x, you just get x. It's kind of like saying the square root of the square of x is just going to get x. And we've done sine, cosine, and tangent inverse in geometry, so hopefully that is something you've seen before. Alright, so the first thing that we need to talk about when we talk about our inverse functions is in order to be a function, it has a restricted domain. So basically we only ever talk about arcsine, arccosine, or arctangent, again, the inverse functions. And again, it's interchangeable, so you could use cosine with a title -1, or you could use arccosine, and the reason is because that starting notation of the one in yellow there ends up being kind of confusing sometimes. So instead, if you say arccosine, you for sure know that we're talking about that inverse measurement. So, taking a look at, let's see, the first one here, which is sine. Sine is going to be restricted into quadrant 1 and then also quadrant 4. Okay. I just made that really weird Roman numerals. Cosine is going to be only in quadrant 1 and 2. And then we also have arctangent, which is back like sine, so it's in quadrant 1 and quadrant 4. Is it IV or, yeah, it is. Gotta switch it up here. Alright, anyway. So, again, that is because otherwise it would not be a function and it would actually, not pass the vertical line test, that kind of thing. Alright. So, taking a look at the graphs of inverse sine, again, the idea is for inverses, right, that the equation is flipped over the y equals x line. And so normally, sine looks kind of like this, right? But now we're flipping it over this axis. And so now it's actually going to look, like that. Okay? And so that's kind of what's happening here. And again, notice that it's restricted on your domain here. Because otherwise, if you don't restrict it, it's going to end up repeating itself and therefore not pass the vertical line test. So, looking at the graph is not necessarily something that needs to happen, but just knowing that your domain is restricted is helpful. All right. The next one, this is going to be your cosine, again, because it's flipping over that y equals x line, and so it normally would have been kind of up here and down, but of course now it's flipping over the axis. Clearly there's an image there that's a lot better than what I tried to draw. Alright. And then the last one, which of course was always weird, is tangent. And so tangent is actually more like a function now versus before when it was this repetitive kind of cubic looking thing. So this one here, your domain is actually all real numbers. And then your range, of course, we talked about being restricted over here, which is a kind of better visualization. All right. Oops. So, first thing that we are going to do here is some evaluations. So remember that this is trying to say arc sine of 1. So if you want to, you can kind of do sine inverse of, 1, not x. Notice that it's saying exact value, and so the whole idea is to use the unit circle. So the way that I like to write this is I'm actually trying to find out sine of what degree or what radian is going to be 1. So sine of what degree is going to be 1. And so if we look at the unit circle, sine that's going to be 1 is your y value. And so taking a look, it looks like this is the only one that's going to be 1. So we have pi over 2 or 90 degrees. And those are both answers. Just depends on if they say in radians or degrees. So we've got pi over 2 or 90. Alright, so the next one, same idea, it's sine, and so we're trying to say sine of what degree or radian is going to give us a square root of 2 over 2. And remember that we are restricted in sine to the negative pi over 2 to pi over 2. So as we look at the unit circle for where sine is pi over 2 over 2, root 2 over 2, let's see, we've got this one, and technically this one, but of course we're not going over to that side of the unit circle. So that means that pi over 4 and 45 could be our answer. Alright. Next one, we've got arc sine of a half. So again, we're trying to find out sine of what degree or radian is going to be a half. Going back to our unit circle, sine is a half here. And so we have pi over 6 or 30. Alright, our next one is cosine. So now we've switched it up a little. Cosine of what degree is a half. And remember that cosine is restricted to that top half of the unit circle. So if we're trying to find when the x value or cosine is a half, cosine of a half is going to be here. And so pi over 3 or 60 is our answer. Alright, the next one is asking when is tangent of some degree or radian negative 1, which means when is sine over cosine going to have probably negative square root of 2 over 2 and square root of 2 over 2, or the opposite. So when is sine and cosine going to be negative square root of 2 over 2 as well as square root of 2 over 2. So taking a look over here, when our cosine and sine, those same distances or values, we've got this one here, where they're at least square root of 2 over 2, this one here, or this one here. And remember that tangent, if we look back at where it's restricted, is restricted to this quadrant 1, quadrant 4. And so we're only looking for, remember that one would make negative 1, positive 1. This one over here would make negative 1. So we're at not necessarily 315 degrees 7 pi over 4, but actually negative pi over 4 or negative 45. Because they're labeling them as not necessarily revolutions around, but instead talking about from this line how much. So we're just going negative versus around counterclockwise. All right. And then the last one is asking, okay, when tangent of what degree or radian is going to make square root of 3 over 3. And this is, of course, a little bit tricky, but that's because we know that they've rationalized the denominator. So this actually was 1 over the square root of 3, but because they don't like square roots on the bottom, it's kind of a no-no, they multiplied by square root of 3 to both sides, and then realized that we get back here to square root of 3 over 3. So because of that, we're actually looking for when is sine a 1, and at the same time when is cosine squared 3. And then, because we know that things will cancel, we're actually looking for when is sine 1 over 2, and when is cosine square root of 3 over 2. And again, these manipulations happen because I know that I ultimately have only certain options to go for, right? In these options, I only know that I can have a 0 or a 1, or a square root of 2 over 2, or a square root of 3 over 2. So, on that note, let's go back. So we want sine of a half and cosine of square root of 3 over 2, and remember that tangent is only on that right side of the equation, of the unit circle. And so sine of a half and cosine of square root of 3 over 2. So that's going to be here. Cosine of square root of 3 over 2, sine is a half, and so we're at pi over 6 or 30 degrees. And of course, you could do this on your calculator by typing in tangent inverse of square root of 3 over 2, and then making sure you're in degree mode, because that will give you kind of more of an exact value of 30. But of course, the whole idea was to use the unit circle. All right. So, next one's, again, kind of the same idea, but now notice they're asking you for the arcsine of the sine. And remember that arcsine and sine are inverses, and so really we're just actually saying this is 45 degrees. We don't actually have to do a whole lot with that one. The next one is a little bit less simple, because now it's not just cosine and arccosine, or tangent and arctangent. It's actually two opposites. So we're going to do one problem first. So the first one is tangent of what degree or radian makes -1. So going over to our, I gotta think about what that is first. We've got sine and cosine. And so sine and cosine are going to be the same number, which only happens at square root of 2 over 2. And then it's going to be negative of that. And we actually did that up here, where we were trying to find tangent inverse of -1. And so we already know it's negative pi over 4. And so now we're just solving cosine of negative pi over 4. Because this over here is pi over 4, and so we plug that into cosine. So going to our unit circle, cosine of pi over 4. Here's pi over 4, and we're looking for the x value. So that's going to be square root of 2 over 2. Whoops. Alright, the next one's here. Doing that inner part first. We've got cosine of pi over 6. So going over to our unit circle, cosine or x value of pi over 6 is square root of 3 over 2. So square root of 3 over 2. And now we're looking for the sine inverse of that, which means that we're technically looking for the sine at which degree or radian is square root of 3 over 2. So sine of square root of 3 over 2 is going to be our y value of square root of 3 over 2, and so that's at pi over 3 or 60 degrees. Alright, and then our last one, lots of stuff happening. So this inner part without the 2 says that we're trying to find sine of what degree is a half. And so sine at a half, looking at the unit circle, sine of a half is right here. So we're looking at pi over 6. So that means that this inner part here is pi over 6, but they're multiplying by 2. So that actually means we're looking for cosine of 2 pi over 6 or pi over 3. And so looking for the x value of pi over 3, that's a half. And there you have it. So again, you could do this in your calculator, literally type exactly how this is, and you would have gotten 0.5 out. But of course, when it says to not use a calculator, it's best to actually not, so that you can find out what the value is exactly. Always get out that unit circle. So our assignment is going to be page 421, number 1 through 31. And of course, we will be recording that in a live Zoom tomorrow.